Hi, welcome to Namis Academy. This time we'll be dealing with combination. Yes, combination. What is combination as related to mathematics? Combination is a selection of items from a larger set where the order of selection does not matter. The order of selection does not matter in combination. So how do we make selection through combination? So let's get into the business of this video. So we have established that a combination is a selection of items from a larger set, and there is a formula to make such selection. And what is the formula? It must be that a particular number of the full part of the population should be selected. So let's for instance take the formula. Let's for instance take an example of 5 persons to be selected. 5 persons to be selected from 20 persons. Be selected from 20 persons. From 20 persons. So we can definitely use the formula of combination to select the 5 persons at a particular time, considering a particular factor. We are going to take some examples to see. Now, what's the formula? The formula says n combination r is equals to n factorial all over n minus r factorial r factorial. So this n now is the number of the population that I'm about to select from, and r is the number of people I'm taking at a time. So for instance, now I have the question 5 persons to be selected from 20 persons. Then using this formula, it becomes out of 20 persons to select. Now n is our 20, so that will be 20 minus 5 factorial multiplied by 5 factorial. Remember what factorial is now. If I say n factorial, it simply means n multiplied by n minus 1 multiplied by n minus 2 multiplied by n minus 3. So I can reduce this to the lowest term by saying 20 factorial is all over 5 would 20 minus 5 would be 15 factorial multiplied by 5 factorial. So this can become 20 multiplied by 19 multiplied by 18 multiplied by 17, 16 multiplied by 16 multiplied by 15 factorial. Do you agree with me? 15 factorial continues to be 15 multiplied by 14 multiplied by 13 multiplied by 12, like that. So if I have 15 factorial, I can just divide it by 15 factorial multiplied by 5 factorial. So 15 factorial can easily cancel 15 factorial. So I have 5 factorial. Remember what 5 times 3 times 2, 3 times 2, 3 times 2 times 1. So let's express that. So we are left with 20 multiplied by 19 multiplied by 18 multiplied by 17 multiplied by 16 all divided by 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. So can I begin to divide to reduce the lowest term? I can say 5 year 1 and 5 year 4. So 4 year 1 and 4 year 1. So I have 3 year 1, 3 year 6, right? 3 times 6 is 18. So what I'm left with, I have 2 years. So 2 year 1 and then 2 year 3. So I'm left with 19 multiplied by 3 multiplied by 17 by 6 multiplied by 16. So if we multiply this together, we're going to have the number of ways that I can select 5 persons from the population of 20 persons. So 19 multiplied by 3 multiplied by 17 multiplied by 16 is 15,504. 15,504. 15,504 ways that this can be done. Let's see the formula we've learned. A committee of 3 people is to be selected from a group of 8 people. How many different committees are possible? So let's go into the solution. Seeing that we are going to select tells that this question is a question from combination. So since we've seen that it's a question from combination, just take the combination formula saying n combination r, which says n factorial. So from this question, we have seen that our n is what now? 8, because we have to select 3 people from a group of 8 people. So the entire population of which we are going to make our selection contain 8 people. So 8, and then our r is 3. So let's input the value of n and r into the formula. So this factor 8 factorial 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 all over 8 minus 3 by 5 factorial multiplied by 3 express this. Remember 7 6 5 6 5 6 5 6 factorial I can stop there over factorial multiplied by, I know 3 factorial is just 3 multiplied by 2 multiplied by 1, so 5 factorial cancel 5 factorial. I'm left with 8 multiplied by 7 multiplied by 6 or divided by 3 multiplied by 2 is 6. 6 times 1 is 6. So I can divide, say 6 divided 6. So I'm left with 8 times 7. And 8 times 7 is 42. 42 ways of which I could select 3 people from 8 people to form a committee. Let's see example number 2. Example number 2 says a pizza parlor offers 10 different toppings. How many different combinations of 4 toppings are possible? So how many different combinations of 4 toppings are possible from 10 toppings? So knowing fully well that it's about selection, we know it's a question under combination. So let's delve into the solution. So we write the formula for combination n combination r, which is n factorial all over n factorial. So n factorial, from the formula or from the question, we could say that our n is 10, right? So n is 10 and that our r is 4. So we can input the value of n and r into the formula. So that becomes 10 factorial all over 10 minus 4 factorial. So that is 10 multiplied by 9 multiplied by 8, 7 multiplied by 7 multiplied by 6 all over 10 minus 4 is 6, so that's 6 factorial. So I can write this with 6 factorial multiplied by 4 multiplied by 3 multiplied by 2 and multiplied by 1. So we can stop here and can say 6 factorial divide 6 factorial. So we are left with 10 times 8 times 7, and here we have 4 times 3 times 2 times 1. So can I reduce to the lowest step? Yes, 2 here 1 and then 2 here now 5. So I can say 4 here 1 and 4 here 2. So I can say 3 here 1 and 3 here 3. So I'm left with 1 as denominators. So let me take the numerators as my final answer. That's 5 multiplied by 3 multiplied by 7 multiplied by 7. So 5 times 2 is 15. 15 times 3 is 30. 15 times 2 is 30, and 30 multiplied by 7 is 210. So there are 210 ways of which I could select 4 toppings from the offered 10 different toppings in the pizza parlor. I hope you understood what we did in this video. Let's take the third example. The third example says a bookshelf has 12 books. How many different combinations of 5 books are possible? Now, if I am to make selections of 5 books in different ways, how many ways can I have that 5 books to be selected from 12 books? So I know that this is about combination, and I can just go into the formula using n combination r. As usual, n combination 7 factorial, correct? 7 factorial by 5 factorial. So let's express by multiply 10, multiply by 10, multiply by 10, multiply 9, multiply by 8, multiply by 7, factorial is continuous, divide by 7 factorial, multiply by 5 factorial is 5 times 4 times 3 times 2 and times 1. So 7 factorial can divide 7 factorial. So can I reduce the lowest term? Yes. So I can say 4 here 1 and 4 in 8 is 2. 5 here 1, 5 in 10 is 2. 3 here 1, 3 in 9 is 3. 2 here 1 and 2 in 2 is 1. So we are left with 1 as denominators here. So let's take the numerators as the final answer. That is 12 multiplied by 11 multiplied by 2 multiplied by 3 multiplied by 1. So 12 multiplied by 11 is 132, right? So 132 multiplied by 2 is 264. 264 multiplied by 3. So let's write 264 multiplied by 3. So 3 times 1 is 3. So 4 times 3 is 12, remainder 1. 3 times 6 is 18 plus 1, that's 19. So 3 times 2 is 6 plus 1, that is 792 ways by which the 5 books can be selected from 12 books. I hope you understood everything we did in this video. See you in the next video. Bye bye.